Hello everyone, a very good evening to all of you and welcome to this second episode of EDUPATH, the journey of success. Now this is a web series brought to you by Expert Group of Institutions Alumni Association, and we are in our second episode this Sunday. Now today we are going to talk about something very different from where we started last week. As children, we are all very curious by nature. Everything that you see outside, you have a sort of curiosity towards it. You have, you see a tree or you see a leaf on the ground, and we are curious about what it is. But there is this one moment of realization that comes to us as a child, the grandness of the universe. This only happens when you look at the night sky. You look at the sky, you look towards the stars, and you realize that the universe is so much grand. There's so much out there to learn and to understand. So this is, I think, is the first time that we are exposed to the wonderful field of astronomy. And today, let's explore some of the facets of this field of science, as well as careers in astronomy and astrophysics. And today we have our guest, Dr. Ishwara Chandra CH, a scientist and an astronomer, an astrophysicist from the National Center for Radio Astrophysics, Tata Institute of Fundamental Research, Pune. A very welcome to you, sir.
Good afternoon, everyone.
Yes, sir.
Yeah,
so,
nice meeting.
I would just like to give a very short introduction of Dr. C.H. Ishwara Chandra. He qualified with his MSc in physics from Calicut University, Kerala in 1992, and then joined the Joint Astronomy Program, that is the JAP, run by the Indian Institute of Science, Bangalore, for his PhD in the same year, that is 1992. The next year, he moved to the National Center of Radio Astrophysics, which is NCRA, at Tata Institute of Fundamental Research, Pune, under this program, that is the Joint Astronomy Program, for his PhD studies on unification scheme for radio galaxies and quasars. In fact, I should mention to our viewers and listeners today that the National Center for Radio Astrophysics, NCRA, hosts the largest radio telescope in the world. That is a 45-meter dish, not just one, but 30 of such dishes are in our country, and we should be proud of it. He finished his PhD in 1999 and then worked as a postdoctoral fellow at the Raman Research Institute, RRI, Bangalore, and later at the ISRO Satellite Center in Bangalore. He joined the National Center for Radio Astrophysics as a faculty member in 2002. And Dr. Ishwara Chandra has over 80 papers in peer-reviewed international journals and has held key positions, including as member of the Executive Council of Astronomical Society of India, member of the Scientific Organizing Committee of Astronomical Society of India, a member of several national and international professional bodies, and as co-editor of the Astronomical Society of India conference proceedings. We are extremely privileged to have such a wonderful personality with us today. So once again, a very, very warm welcome to you, sir.
Thank you.
Yes,
Thank
sir.
you for nice
So
words.
when we come to astrophysics, right, it is, first of all, I think I want to ask you, what is astrophysics? Because many students, they may not be aware of what astrophysics is, or, what does an astrophysicist do? So maybe you can just shed some light on what astrophysics means.
Yeah, surely. Yeah. So astrophysics, it's a branch of physics, just like you say quantum mechanics or classical mechanics, which basically astrophysics also uses physics as a tool to study various phenomena in the universe, like how does sun burn and gives us light. That is one thing. And if you go beyond our solar system, how does the rest of the stars behave either in a group or in a certain way? Why does galaxy become so big? And many such studies. Basically, it uses physics, but objects
Right.
in the sky. So that is how it is. Astronomy and physics
Yes,
combined,
sir.
it is
And what
astrophysics.
inspired you to choose a career in astrophysics?
Since my childhood, I had some interest in looking at sky and stars in general. Night sky, because I was in college days about 35 years ago, mid 1980s. So that time, because we are from agriculture family, so there used to be like we used to go to paddy field for watering at middle of the night because there is a little water was coming, and that was supposed to be divided among several farmers. So I also used to go at maybe sometimes 3 a.m., sometimes 11 p.m. So that time, suppose you have to spend 1 hour there, then you look at sky and enjoy the stars. So some interest started from that kind of observation. Then naturally from school days and college days, we had right set of friends who had also some similar mindset. Then that gradually developed into college days, and during BSc, I had good teachers in college. And one of the teacher was astronomer and joined as a lecturer in our college. So he encouraged, and another physics teacher was very supportive. So it actually grew from what was started as a just not just interest and looking at some wonderful sky, and it became like a major grew up in as I studied my BSc.
Okay. So, well, speaking about a career in astrophysics, because you are a physicist by heart, and then I think it grew out of passion into
Yes,
astrophysics in particular. Now, fields like astrophysics are not generally
exactly.
considered as conventional career choices in our country, especially. In India, students are, and also more than students, I think their parents are pretty much obsessed with engineering and medicine as the default career choice in the field of science, especially. It could be even not just astrophysics, but even when it comes to pure sciences, and in particular, since you are in this field of astrophysics, it's considered a very risky choice. So how can a student, as a student, how can they overcome this risk factor associated with such unconventional choices?
Yeah, it's a good question because during my time when I joined for PhD for astrophysics, I might not have thought much deep into that what to do after PhD and what are the job prospects. That time my interest was that I want to do astronomy. I want to do PhD in astronomy. So that time, even just after MSc, even though I had some local job offers because we are from poor family, we needed some job to earn our bread. So even then that I had to give up and then I have to aim for this PhD. So finally I got succeeded in getting IISc. But the question is correct that what is the relevance means what is the job market? We
Correct.
call it as job market for astronomy. So the job market from physics is better than astronomy. The job market is becomes narrowed to the institutes which does astronomy. But there is one thing is also true that if you are good in your field, then there is no shortage of jobs. So suppose that also means that you have to be best all the time. That kind of pressure exists. But in general, it is true that astronomy, the job market is slightly less compared to, for example, solid state physics or condensed matter physics, those kind of branches. The job market is slightly less. But astrophysics is also physics. So for teaching jobs in physics, astrophysics and physics are considered same.
Yes.
Because that kind of option, there is no difference between physics and astrophysics for teaching jobs especially.
I think what we need to learn from this is that no matter what field we choose, it is necessary to be good at what you do. Even with conventional career
Correct.
choices like engineering, we hear in the news that about 80-85% of engineers are unemployed. The question is, they're not just unemployed,
Correct.
they're unemployable, in fact, because they lack the necessary skills required. And I think if you are a good engineer, of course you will have jobs for you out there. If you are a good physicist or an astrophysicist, you will definitely have jobs for that as well. I think this is what students need to realize. But coming to a more
Yeah.
basic, yes, sir,
Can I
yes, sir.
add one more? Yeah, just I wanted to add some couple of years back there was a newspaper article which I forwarded to many people, which said that IITs and ISERs, which are the premier institutes, their 40 to 50% faculty jobs are vacant. That is because they are not finding right candidates. So that's what also it means that if you are good,
Correct,
there are job
correct.
options available.
So,
Yeah.
talking about being good at something, there's a student who has sent a question. So, I would just like to read it out. So, he says, "Sir, I love physics as a subject, but it is a bit hard and complicated to understand. Can you give me some tips to improve my interest in physics even more?"
Okay, so that is see this interest in subject is basically it comes from within. But if you are some liking for a subject, you can develop by probably day-to-day life or something. Suppose you are traveling in a bus and driver suddenly applies a brake and you fall front. Can you connect with your something with the physics?
Yes, inertia.
That kind
Yeah,
of this
inertia.
thing is
Yes,
also.
sir.
And if you are slightly, if you are in BSc level or something, then probably what you can connect is like y equal to mx plus c is a straight line equation in mathematics, but Ohm's law v equal to IR is also same. So you can probably connect between physics, mathematics, and this, and then probably you can develop a much more curious interest in physics. I used to enjoy this kind of small connections. That is how my interest got developed.
Yes, I think curiosity is something that is very, very crucial to the kind of understanding that's required, especially in physics and astronomy. Uh, and this sense of wonder is key to any field of research, especially, and especially in sense of astronomy. Now, is this curiosity something that is a part of us from birth, or can it be developed as we grow? Or and is it also too late to ever develop curiosity if we have not developed it as a child?
So it is never late, but you should have some curiosity to begin with. Then you can eventually develop into more and more something, more and more curiosity. See, once you start seeing something, probably you don't take your eye out of it immediately. You keep observing. Okay, let me see more. Let me observe more closely, or something like that. So we do in our research. Then we look at the stare at the image for several hours or several days, and sometimes we may find something new which nobody had thought about it. So it's a patience and curiosity, and also you have to have clarity what you are looking for and what is there, what is not available. So there's some kind of background also you should need when you are looking at a particular subject, and then you can actually think in that deeply in that direction. It
Right.
can be developed. Yeah.
Right. I think just to add to this, I feel that we are all born curious, but I think it's kind of beaten out of us as we grow up, and our curiosity kind of decreases because children by nature are curious. They always ask, "What is that? Why is this like this? Or how does that happen?" But many parents sometimes say, "Don't ask too many questions," or we'll see
Yes.
that later. But I think we should always encourage people to ask questions and be curious. Uh, Now, Generally, when we think of space, when we think about space science or astronomy, we generally associate with physics because we've been talking about physics for so long. But my question is, are subjects like chemistry or biology, are these relevant to astronomy or space research in any way?
This is a good question because there are lots of molecules in space. So whether it is chemistry or biology, people think that life has come from space. That's also some kind of theory. See, basically, what I will tell, what you can also imagine. Suppose you give right kind of temperature, humidity, environment, and etc. Some chemical reactions will happen. So in space, there are like hundreds of molecules. So something interesting, one interesting molecule is alcohol. So in space, there is supposed to be trillion liters of alcohol available in space. Just a curious input. Acetaldehyde, benzene, so many molecules are
Right.
there. We are also
Correct,
out of
correct.
space,
We're
right?
all. I think it's the same. It's
So we are
important to
just
realize here that the atoms that make up everything in space are the same atoms that make us also, and the atom.
correct,
Yes,
correct. So we
correct.
also
The elements that are most commonly available in space are also the most commonly abundantly available elements here. So we are all just space stuff basically.
correct.
Uh, so just a more curious question. A student called Dhruva has asked. He has a doubt about black holes. So are all black holes
Hmm.
a result of death of a star, or are there other phenomena that can lead to black hole formation?
No, there are many other phenomena. It is need not be death of the star itself. See, all by definition, we go back to what is black hole. Black hole is an object where classically means it's a in real sense it is much more complicated mathematics. But for a common man, what we can tell is that it is an object where escape velocity is more than velocity of light. That is how we can think it in some rough way. So any object which is so compact and so dense where light even cannot escape, that's a black hole. So it need not be out of the death of the star itself, but death of the star is also one way. But other than that, at center of galaxies, now it is believed that at the center of every galaxy, including Milky Way,
Right.
there is a black hole because center is so much dense and the matter condensed into such a tiny volume and that has so much gravity as that even light cannot escape. So recently there was a confirmation about a black hole by Event Horizon Telescope. So Dhruv can Google the Event Horizon Telescope and find more about it. That what is the typical
Okay.
size of the black hole? See, if Earth becomes black hole, then it will be
Oh,
3-inch
okay.
size.
Yeah, I think it's the density
What
that
mass of the it
matters.
will be yeah, it is like a density that matters. Yeah,
Correct.
just compact and dense.
That's a very interesting fact that if Earth was a black hole, it would be just about 3 inches wide. Uh, So
Yes.
you were just talking about the Event Horizon Telescope, sir. So you specialize in radio galaxies, and you use the GMRT, which is the Giant Meter Wave Radio Telescope in near Pune. So what is so special about this
Mhm.
telescope? It's right here in India, but many of us are not aware of this. So and also, what is so interesting about radio galaxies that you study that makes them relevant to research today?
Yes, yes. So I will tell you about telescope first. So our telescope consists of 45-meter diameter dishes and 30 of them arranged in a Y-shaped configuration spread over about 25-kilometer area. So it effectively means, since we are spreading out in 25-kilometer area, it effectively means a telescope of the size 25 kilometers. So the resolution of a telescope is lambda by d. Lambda is a wavelength, d is a size. So size for us is not 45 meters, but 25 kilometers. That is how cleverly the signals are combined. So that gives you a very fine resolution to look at an object. And this is the largest telescope operates in meter wavelength, like less than 1 gigahertz frequencies. So but radio galaxy, coming to radio galaxies, it's if you look at in the optical picture, the radio galaxy and not radio galaxy, you will not find any difference. It looks very similar. But if you look it in the radio window, that is electromagnetic spectrum, the radio part of electromagnetic spectrum, you will find plenty of radio light coming out of it. much more than the size of the optical galaxy. The size of Milky Way is like 100,000 or 30 kiloparsecs, like 100,000 light years of that size. This will be 10 times, 100 times bigger than the optical size. Narrow jet, and people believe that the power, the origin of such a radio emission comes from the black hole in the center, and that is very compact size. So very compact black hole in the center, very small size, maybe slightly bigger than the solar system size, and then that power emission which is much more than the size of the galaxy. So that is how it is very, very curious. And my research is mainly about this, how this galaxy, there is also theory that this galaxy switch on and switch off.
Okay.
So that is widely accepted, but nobody has any clear idea that how many times it switch off, and why it switches off, and what happens after switch on and switch off, and various kind of thing about it's called episodic activity, birth and rebirth, death and rebirth, that kind of phenomena. So
And
my
these
interest is in
switching on
that
and
kind
switching
of
off, it
phenomena.
happens periodically as in a regular period, or is it random generally?
Yeah, these things are not known. So people know in the sky about maybe just less than 100 such objects in all over the sky the last 20, 30 years. Some of them are known with, actually most of the objects known are only twice born. And there are only 2 or 3 objects which are thrice born, and one of was discovered by us.
It's very, very
in the sky, yeah. So this is the
proud
kind of
that so close to our home and hearts, such good research is happening.
Yeah.
Sir, there is one student who has asked a question. Is it necessary to crack astronomy Olympiads to pursue a career in astrophysics?
Not at all. That's a good question, because many people have this misunderstanding that to do research in astronomy, you need to know astronomy. I even though I had some, there was not a single question about astronomy if you are joining for a PhD in astronomy, because all the institutes which conducts this PhD program in astronomy, they know very well that there is no astronomy MSc in anywhere in India. Second thing is that what is needed for research is a good physics background, because after all, astronomy is actually physics applied to astronomy, right? Astrophysics.
Correct.
So as long as the student has good physics knowledge and zero knowledge of astronomy, that is perfectly fine. There
Right.
will be interviews and tests, and that has to be qualified. That is the
Right.
only requirement.
Right. So, talking about a career in astrophysics, so many students, they say that they want to become a scientist. They have heard this term scientist many times. I'm a scientist, or he's a scientist, but they are not really sure what being a scientist means. Because of course, being a scientist, you could be a scientist in many different fields. But they've just heard this term scientist thrown around in the media. So, what does actually being a scientist mean, and how should a student become a scientist?
Yeah, that is because there are also some general public sometimes think that scientist means they have to discover. That need not be correct. A scientist can explain something which was not explained before. Scientists can model a phenomena which was not modeled before. They can, of course, they can discover also in that process. So many such things they can do. Basically, a scientist's job is to advance the field. Like in medical science, you can see that medical science has advanced, more medicines have come out. And in electronics, you can see many things have advanced, like nanotechnology, and many things have come out. In space, you can see the things have advanced. Now people can launch bigger vehicles, people can launch with more perfection. So basically any subject, you are supposed to advance the subject from reduce the number of unknowns to unknowns, and then you can add more knowledge to the subject.
So I think, as they say, you're standing on the shoulders of giants. So somebody has done research before you, and you stand on their shoulders, and you do even more than what they have done. I think
Correct.
advancing
Correct.
the forefront of any field, I think that is what being a scientist means. Now, we're getting a lot of questions from students. Let me just take a few.
Yeah.
Interestingly, there's one question here which I actually wanted to ask you anyway. So, Now, anyone who has ever done some sort of sky watching with the telescope, a simple telescope, knows that patience is very, very important in astronomy. Of course,
Yes,
when
yes.
it comes to even large scale observations that you and your team do, I'm sure patience is even more important because sometimes there may be a lot of waiting for several months or years without really getting any useful observations. Now, how does one cultivate this virtue of patience? And a student has also asked, Purti Naganir has asked, how do you develop a sense of patience as a student or as from your academic life? How do you develop that sense of patience?
One thing in astronomy is that if you are interested in astronomy, the subject will get you patience. Because astronomy is not, it's not an active science, it's a passive science. What I meant is that you are at the mercy of the star or galaxy to emit light. Right? So suppose your observation is scheduled tonight and there is a cloud and you have to wait for the clouds to go away. Or suppose you are observing galaxy, that galaxy flux is varying, and the day you observed the galaxy was faint, and next day it became bright. So many things will tell you that okay, you are not getting the right thing when you want it, and the patience is important because if you don't have a patience, you may miss some information what is there in your data. See, you should note that sky was blue for many years, right? Thousands of hundreds of years, sky was blue. But C.V. Raman thought about it, and then
Explain, correct.
the Raman effect we all know. So something which is always there, if you are not patient enough, if you are not curious enough, you may miss. Which is after somebody finds or explains it, then oh, I also saw. Now everybody knows sky is blue because of certain the Raman effect and the scattering of light. But before that, nobody knew, right? But sky was blue before also. So what is basically saying that if you have patience and curiosity, and then you have a higher chance of cracking something or making progress on a subject. If you just look at quickly and then go to the next one, then you will never. It is difficult to make progress. So you have to develop that habit. That something is there, I want to know, and maybe you look at literature and figure out that okay, this is something new. What I am seeing is
Right.
something new. People should not assume that what I am seeing might have already been done, so therefore I will not pay attention to it. Many times it has happened that obvious things which people thought might have been done is not done. So you are the first one to point that out.
So obviousness is something that we should not take for granted. And speaking of passive
Correct,
science,
correct.
I think some of us don't realize that whenever you look at the sky, you look at the stars or any astronomical observation, we are actually looking into the past because light itself takes
Yes.
time to reach us, which means that by the time you observe it, already several years or millions of years might have already passed by the time that light has reached us, and that event has already occurred. So I think it's actually like a time machine. You are actually looking into the past. We're getting a lot of questions. Some of these questions are, in fact, very curious questions about the universe. So I think we can take a few of them. Uh,
Yes.
so
Sure, sure.
somebody has asked, so which is the nearest black hole to Earth, and is there any effect of it on us?
Within our galaxy there are many black holes like stars, X-ray sources. The black holes are known through X-ray sources because that's the first time in 1960s when people discovered X-rays from stars in the nearby hundreds of light years away, like Cygnus X1, then GRS 1915. There are many objects like that. Cygnus constellation was the famous one. Scorpio X1 was another object. They are not too far. They are like 100 to 1000 light years kind of objects. So when that X-ray was observed, two was hypothesis, means only black hole can produce such X-ray and rapid thing. So, but they are like stellar mass black hole. They may not be too much massive than Earth, Sun, like 10 times bigger than Sun or maybe 20 times bigger than Sun. And because they are so far away, they have no direct relation our solar system and Earth. But the biggest black hole near to Earth is definitely the center of Milky Way.
Yes, a supermassive
So
black
that's
hole.
about
Yes.
more than a million solar mass. Yeah, million times the mass of Sun. But these kind of small black holes are everywhere within our galaxy, and there is no
I
direct
think as
effect
long
on
as
them.
we are outside the event horizon of any black hole, we should be safe.
Yes. For a black hole of sun's mass, event horizon is 3
Oh,
kilometers.
okay. So nothing to be scared of then.
Then you are sufficiently far away.
Yeah, yeah. No, I think there is this misconception that black holes are like giant vacuum cleaners, that they suck everything inside, which is probably not so true. It only,
It is true when it's close.
correct,
Yeah.
only inside the event horizon.
If you are close to the black hole, it is true.
Correct,
Yeah, very close to the event horizon, it is
correct,
true.
correct. So a lot of questions on black holes that we're getting. So there's one student called Vatsal who has asked, so according to many films, black holes are the shortest distance
Hmm.
between two galaxies. Like, I think they're talking about traveling uh, instantaneously between two galaxies or two parts of the universe. Is that true?
So that is because I don't, but these things are, some of them are mathematical. Because there is also people are saying you can travel back in time. Students is saying that suppose there is a quadratic equation, ax square plus bx plus c. Quadratic equation has a two solutions, right? One is plus and one is minus.
Right.
So suppose that quadratic equation you solve and you get a solution. Suppose the solution is about the height of a human being. So minus has no meaning,
Right.
right? So your school teacher will tell you that you have two solutions. One is plus 6 feet, other is minus 6 feet, but minus height has no meaning, so therefore ignore it. That is how we are taught in the school and colleges. Minus and plus both are valid solutions.
Hmm.
So many, all these fantasies about you can travel back in time, you can reduce this, they are all mathematically correct,
Right.
but it is difficult to visualize.
Hmm. Because I
I
think
think this
there
is
could
the
be some
somewhere.
physical feasibility in terms of physical laws also, in terms of
Yeah, so
entropy or arrow of time. Uh, Now,
they are mathematically correct.
correct,
That's all
correct, correct.
I will say.
Uh, so I think these students can become astrophysicists one day and actually figure out if these things are true or not.
Yes.
So there are a few questions coming in. Generally, when we talk about astrophysics, uh, we are looking at something that has already happened. We are looking at the past of the universe, finding
Mm.
about our past. But there's a student who has asked, what are the benefits
Mhm.
of astrophysics in the future? So how is it relevant to the future?
Future means
Our
future of
future, I
astronomy
think.
or future of us? Future of us, yes. So that way, if you actually see astronomy, maybe I am taking the question as that essentially that why do we have to do
Right.
astrophysics? Or
Correct.
in what is the benefit of that kind? There's also because they are related to it. See, astrophysics uses or any pure research uses technology which is much more advanced than what is available in the market. So, for example, the Future Radio Telescope, which is called Square Kilometer Array, which is hosted by 10-15 countries, where India is also a partner to it. And you might have seen newspapers saying that the brain and nerve of this telescope, which is entire control manager, is being developed by India, and our institute is the nodal agency for developing such a massive system. And those requirements are such that even the most powerful computers of the day cannot handle the data rate, cannot handle both data recording rate. So what happens is that companies like IBM, Intel, and all these big mega computer science companies, they show a lot of interest for, because for them astronomers posing such a challenge that I have a big telescope which can do most means complicated observations of the sky, but my data rate is something like 1 terabyte a second or something like that, which is very difficult for a computer to record that kind of speed. And you want to communicate between the two computers, etc. So right now there is already infinity path, but there is much more than infinity path is required to communicate. So all these tech giants are showing interest. This usually happens not only in computer but in typical many other facilities like signal transport or digital computation everywhere. The pure science puts requirement which is much more than what is practically capable. So a lot of technical advance happens because of pure science. That is one. And then as an astronomer or scientist, you are the one who are pushing for it. That I want much more than this. I want to analyze my terabytes of data in 5 seconds and give a real-time judgment. These are all very complicated. Something as you are observing, supposed to discover some exotic objects, you are supposed to analyze some terabytes of data in judgment. Should I keep the data or should I delete the data? These are very, very challenges, and all the big computers across the companies like IBM and all those, they have taken this as very seriously. And this is a kind of enthusiasm. Even for engineers, this is an interesting path, that pushing the technology to the limit possible.
Okay.
So that is a kind of joy in that, right? Whether it's astronomy or particle physics or biology, your aim is to push the boundary of technology.
Okay, so speaking of pure sciences and how they help actually push technological boundaries. So, have there been any instances of research in pure science or in astronomy or astrophysics that has actually led to something that we are very familiar in day-to-day life?
Right now we are doing the internet.
Yes.
Right. This happens in internet. I am in Pune. You are in Mangalore. So internet came out of CERN pure research. Wi-Fi came out of CSIR Australia, which is also astronomy pure research. And launching of satellite, that is because of astronomy, you're computing the gravity and motions of the planet and how to do that. So without launching of satellite, today's entire communications will go. And CCD cameras, there are a few examples I am telling. CCD cameras. Now CCD cameras are so good that they can do high dynamic and good imaging. And more importantly, not only this kind of technology in medical. So when you say CT scan or MRI scan, people don't realize what is in the behind. So the technology is that how to diagnose the image or how to get the somebody looking at the image, they will say you have this, you have that, and so somebody has identified, analyzed that image. That algorithm was basically radio astronomers algorithm. So an algorithm used by radio astronomers has been in use for CT scan and MRI, those kind of places. So there are a lot of crossbreeding happens, plenty of crossbreeding happens from pure research to somebody, some other branch of science. So this is probably public is not aware of it. But did the radio astronomer develop the imaging algorithm for MRI? No. But because the algorithm is so complicated, there was similarity was found, so it was used for MRI. Now today, if the MRI diagnoses things correctly, the radio astronomer has to be thanked in the behind. So there are many such examples in the behind actually. Pure science, pure science research leading to the practical applications.
So now, generally, a lot of students, they are very scared to get into pure science directly. Maybe because of not having awareness about the subjects, or it could be due to peer pressure or parents saying, no, you do engineering. It's more safe. So is it possible after pursuing engineering degree, after doing a BE or a BTech, can a student, after that, once they are more mature, they develop that interest in pure science, can they enter into the pure science stream after engineering?
Very well. This is a very good question, because many people think that they have to do for getting research, getting into pure science research, they have to do pure science degree. That's not correct. In our institute, we have 15 faculties. Almost half of them are with engineering degrees. Electronics communication, ENTC, then some years ago, somebody with mining engineering also joined. So what it means is that as long as you have a bachelor's degree or master's, whether it is electrical engineering or electronics or computer science or any branch of thing, as long as it is bachelor's degree or master's degree, that is enough for you to, that qualifies for you to apply for the entrance exam and interview. What is required for us is that as long as you qualify the test and interview, then our many institutes give admission to such candidates. People study physics as a during the free time or spare time as a second hobby during their engineering degree. That's how they are able to qualify this exam. So there is no prerequisite that this you have to do this. There are people who actually quit IT jobs and then come to research because they find it so monotonous. They do this because there is a lot of parental pressure. But your other point is very valid. The engineering jobs are safe. Means suppose your family background is such that, or you wanted to be comfortable, that you want to earn certain amount of money as early as possible for a good living, then pure research may not be the right place, because after your bachelor's or master's degree you have to spend at least 5 years for PhD. After 5 years you have to spend at least 3 to 5 years on postdoctoral fellowship. This like 8 to 10 years is a kind of Trishanku state. You are not sure exactly where you will be. You may be anywhere in the world, because you are supposed to be. You can be any, whether Europe, Australia, or US, anywhere in the world, and you may have to change the jobs in between. Every 2 to 3 years you may have to change also. Then you will get a regular job. So when I got my regular job, I was 33 years old. So that is one for it. Suppose you enjoy your work, then this is probably the best thing. You get paid for your hobby.
Right.
So this is not seen in anywhere else. Yeah.
Right. So, speaking about students of the class 11th and 12th, what is the best career path after 12th standard or plus 2 to get into astrophysics?
They can do pure science degree in ISR or IASC, or they can do engineering if they want. If they think that they wanted to play safe and do that, and then they can study physics during their free time, and then prepare for entrance exams. But there is one thing different for the current generation students compared to our generation. During my generation in 1980s, 90s, because of the family background, there is a family pressure to earn a living as early as possible. Most of the students, or for most people in this generation, there is no such pressure. So they need not start a job immediately after their degree. So they can take several years of higher degree and education, and then they can look for a job. So that difference is there. They very well, after their engineering or BSc degree, can go for PhD and other options. But PhD people also can go back to industries. Nowadays, that trend is increasing, and that's also one option is there. Urgency to go to your to start earn a living, so you have more freedom to play around.
Right, right. So we will just take a few more questions from students, because a lot of questions coming in, and a student has asked, sir, why did the Big Bang take place, and what is dark matter? Student's name is Yashas. So he has asked Big Bang and dark matter. Yes, sir.
Dark matter. Dark matter is basically a matter which has no presence through light. Radio wavelength or X-ray, gamma ray. See, electromagnetic spectrum is a wide spectrum from gamma ray to radio. So as long as the matter emits some radiation in any part of the electromagnetic spectrum, it need not be visible light. It can be radio only. It can be gamma ray only. Anything is fine. So any matter which emits light anywhere in any part of the electromagnetic spectrum is not a dark matter. But gravity is something which is felt by some matter which is there, that is inferred from the gravity. So there is a famous thing called rotation curve of the galaxy. So people know how fast the stars are moving around the galaxy. So just from the speed, that how fast the stars are moving at what distance, a simple 12th standard physics equations, and that will tell you what should be the mass. Simple velocity and mass relation. But and then you actually add up all the mass known to you through light, radio, X-ray, optical, all put together. They are not matching at all. There are like 80-90% of the matter has to be dark. Means its presence is felt only through gravity. There is no light coming in. That's why dark matter. And Big Bang happened that's a difficult to concept, because Big Bang is a thing which is an event. It's an event which is supposed to have started the universe by itself. So before Big Bang started, universe did not exist. That is how it is proposed. So people give a comparison as like a balloon. like you put air into a balloon and balloon becomes bigger and bigger. So that on the surface of the balloon, like our galaxies are there. But at one time the balloon was compact. So that time space was compact. So that is how people visualize this Big Bang, that it came out of nowhere. There is also another theory that Big Bang happened everywhere. That's also another theory, which means that space is getting created everywhere. So some of them are like, it is difficult to visualize, but they are mathematically, there are many mathematically correct expressions to explain this.
So there are a lot of questions coming, interesting questions on aliens now. So, yeah, so just to understand, because especially when it comes to radio astronomy, I think there are quite a few radio telescopes around the world which are searching for signals that are not coming from any of these celestial bodies, but coming from extraterrestrial intelligence or in terms
Yes.
of aliens. Now, is there something that is happening in India in terms of research on this as well? Because we have heard of the SETI project, Search for Extraterrestrial Intelligence.
Yes, yes.
In the US, there's a lot of hype
That's the
surrounding
thing,
this
yeah.
also. So, what is the situation? Because of course, looking at probability, of course, there has to be life somewhere else in the universe. It is huge, the universe, but it may be so far away that
Yes.
the universe is so huge that we may not have ever encountered that kind of signal. But what is your take on this?
Yeah. So there is something called Drake equation. Drake equation, basically it's a probability, like you said, it's a probability based argument saying that out of so many millions of billions of stars, there will be certain fraction of the stars which will be exactly sun-like, and for those many sun-like stars there will be a planet Earth-like, exactly one astronomical unit away from the sun, and because it's exactly the same position, there is nothing unique to Earth. For any sun-like star, if there is any Earth-like planet exactly the same distance, then it will have the life like this only, because it will have right kind of atmosphere, right kind of temperature, etc. Many tens of thousands of Earths should be there across the galaxy. The problem is the signal strength. So as you go, the signal drops by 1 by r square. So that because of the signal becomes weak and weak, but intelligence has to be there or life has to be there everywhere, because even in our galaxy there will be some life, and there are billions of galaxies in all over the universe. So we are nothing actually in the world. There are billion stars in our galaxy, and there are billion galaxies. So there are like billion. Out of that, we are one. So it's like one speck in the whole like oceans of sand or something like that. And what is the other question? Other
SETI.
question is about SETI, right? SETI. That one explanation which I liked it, because suppose this some extraterrestrial intelligence actually came some like 200 years ago, and they were radiating some signal. We didn't have the technology to catch it, right?
You're right.
Or suppose they are radiating something even more hi-fi than our technical capability. We think we are technically superior, we have a lot of technology, but there may be aliens who are much more superior even if they exist. I'm just telling that even if they exist. So our technology did not match. They may not be having the same kind of radar, same frequency, same electronics. They may have a totally different one. There is also another thought that it's carbon based versus silicon based, because carbon silicon are same family, right? So we can have our life is carbon based and their life can be silicon based.
Right.
So there are many such arguments, but this is nice. It's a nice thing to read, but this is the kind of curiosity which should be
Correct.
there.
Correct.
And one of the students who did PhD in our place has gone to the SETI program because he liked this kind of topic, and he is doing good job there in Caltech. Yes.
Okay. Um, so speaking about technology, it is always rapidly changing. Technology changes because you just said, 200 years we had some other kind of technology. Uh, and now we have something else. 200 years from today, maybe technology is different. In fact, forget 200 years. Last
Yes.
10 to 15 years also, technology has changed very, very rapidly. Now, how has this
Yes.
technology affected your work, your research in astronomy? You could be positive or negative, but how has it affected this rapidly changing technology?
No, most of it is positive only because computing has increased. But along with that, the data size also increased 1,000 times in the last 20 years. 1,000 times it has increased. So what is becoming is that instead of you are analyzing data in front of a normal desktop computer, which was possible maybe 20 years ago, now you need a supercomputer to analyze data. And what you could do in 2 days, you may need a month. And you need a lot of patience to it, because at the end of 1 month you may realize saying that your image is not as good as what you thought to be, because this is a very complex analysis, right? So you don't know which parameter to tune for what kind of corruption which happens in data, like adding extra signals coming from man-made sources. So technology has definitely has helped as well as made the research more complicated because of the huge volumes of data.
Yes, sir. I think especially when it comes to just to mention a negative impact, especially when it comes to optical astronomy, optical telescopes.
Yes.
I think with the amount of artificial lighting that we have in the cities, and cities growing bigger and bigger with lot of bright lighting, people who are using optical telescopes are, I think, struggling these days because of the light
Yes.
pollution from cities.
Right, right. Same thing is happening in radio telescope also, because all the
Right.
any electron is a agricultural machine or whether it's a motorcycle or any vehicle, they produce a sparks.
Right.
And this actually affects the radio telescope, because if the radio telescope is sensitive for extremely faint signals.
Hmm.
So even if you put your mobile handset in Mars or something, you can still detect it. It's that kind of sensitivity. So anything, any electronics device, any electrical or even simple electricity wires, simple electricity board wires taking power from one district to other district, they also emit noise. This is
So
called
what
radio
about
frequency
these
interference.
especially people like Elon Musk? They are trying to have this entire mesh of micro satellites which can provide the Wi-Fi to the entire globe. Won't
Yes.
those also cause an impact for radio
They,
astronomy in the future?
yeah, they will be, because there are a lot of commissions available, and our institute is also discussing with the government. So as per the international convention, they are supposed to emit only in the permitted region. So there is also protected radio astronomy band.
Hmm.
They are slightly narrow, but they are protected by international convention. So no commercial establishment can radiate in those protected bands. So there are a lot of regulations available. But still, what can happen is that even if the leakage is 1 in a billion, that is enough to spoil the telescope. And such a technology may not exist with anyone, because they may not be able to stop the leakage at 1 in a million or 1 in a billion level. So that is effectively affecting. So radio astronomy is also getting corrupted exactly the same way optical telescopes.
Yes, sir. Sir, a student called Purvi Hallur has asked, time management is important in every aspect of life. How does it play an important role in astrophysics? Time management.
Time for
Yes, sir.
working,
As
mean
a
the time
student
for
or
work.
as
Yeah.
a somebody who is doing research, how does time
Correct.
management have an impact, sir?
Time you are see between various activities and research. Usually scientists have a tendency to bite more than they can chew. So in principle, what can happen is that if you are not good in managing your own job properly, you may spend time in projects, and at the end of 2 years, none of the project might come to a conclusion. So time management is very important. You have to stay focused on a certain jobs. So one technique what people do is like called busy weeks. So suppose there is a collaboration, and then 1 week everybody will agree. This 1 week from Monday morning to Friday evening, I will not do anything else, but only job related to this particular project. Bring this to completion. So this is the kind of techniques which are used in time management to speed up the project. This is a nice concept. It is called busy week.
Right. There's a viewer called Ashwin Nayak. He has asked a couple of questions. Question one is, how do you eliminate information uh, in radio signals given all the noise that you mentioned with respect to electromagnetic interference and radio interference? How do you eliminate that noise? or how do you narrow down the required information? And the second question he has asked is, does NCRA involve in any technology transfer with local industries? Is the question. Yes.
Okay. So in the regarding the first question, there are theoretical calculations actually come to our help. Suppose you are observing a star at a particular direction in the sky. There is something called fringe fitting. So you know the direction, so you know the phase of the signal from what direction. The moment the direction is different, the phase is different. So as long as the interfering signal comes from a different direction than your target, and in computational way you can identify that they don't have the right kind of fringe or right kind of phase. So you know the Young's double slit experiment. So the moment your source is slightly off, the fringe will go in slightly off. So that way you can eliminate that which is signal coming from a source, which is not coming from your source. So anything which is not coming from source, you can eliminate from that kind of technology. It's a huge computational work, but it is not impossible. And a lot of technology transfer locally is also happened. For example, you may know the Tata Indica car. The antenna in the Tata Indica car was done by a couple of engineers in our lab. And there are also like low loss optical, low loss cables, and there are local industries also showing interest in technical knowledge, like how to transmit a signal with minimum loss from one place to other place, and this computational information. Like NVIDIA graphics, for example, they showed interest because we have shown that the CPU usage can be 95% uptime all the time, like maximum usage. So there are many local industries also showing interest because we push the boundary, right?
Right.
So that's how they are
So
interested.
talking about collaboration between industry and all that, but also these days in almost any field we see that there's a lot of competition between different countries. So in terms of astrophysics and astronomy, how is the situation in India versus rest of the world, and also is there competition between these countries or is there collaboration?
The collaboration is much more than competition. Competition happens at probably some friendly competition or mild level, but collaboration is much more prominent because people collaborate. India has, because the GMRT, as you said, it's the world's largest telescope. So astronomers from India are also among the good astronomers in the world, maybe within top 10 or top 5. So people are generally, our community is not too big, few hundred good radio astronomers all over the world. So generally we know each other and there is a good collaboration between them. We complement each other, our expertise. If GMRT is a low frequency telescope, somebody working in a high frequency telescope, they may want to collaborate because we can combine the information in high frequency and also low frequency and get more information about a galaxy or a galaxy. This is kind of competition.
Right.
More collaboration. Then there is also no commercial interest, right? We are not making money.
Correct.
Therefore, there is no reason to be competitive. So collaboration is more beneficial than competition.
Competition. I think it's actually good for us also that when it comes to astronomy, we all share this one planet. It is good that we collaborate with each other, and it helps us develop an understanding of the place that we are in. So we
Yeah.
have just only about 2 or 3 minutes left. So we will just try to wrap up with a couple of small questions. Um, have you ever had a research project that didn't quite go the way you intended it to? And how does one handle failure in such situations?
Yeah, so that's a good thing because see, there are a couple of things that helps in scientists' favor. One is that we don't put all eggs in one basket usually. Every scientist will have multiple projects going around, and failure happens once in a while. Even I had some of our project. My first thesis project didn't go through. It was not accepted by the international committee. Then we had a second one which was very successful. The one paper out of that is also very successful. But later also in some another kind of failure sometimes is more beneficial than success. The example I will tell you that we started looking for signal from extrasolar planets. It was predicted saying that the flux from these planets should be like 300 units, 500 units, 700 units, and we had a sensitivity to detect even to 5 units if it were there. It was comfortable, and we observed 10 of them over 3-4 years, and none of them we found signal up to a few units. So when the prediction is 500 and you don't find up to 3, so that means what? That's that non-detection or the failure of detection is more important than the detection.
Right.
So the whole theory got changed. The whole prediction, the scientists who predicted this theory had to go back and rework that why, what was wrong with the prediction. The whole physics was getting changed. So one failure is like your experiment is completely failed, it did not even happen. Second failure is that you expected to detect something you didn't detect. Sometimes the negative results are more important than positive results.
So I think it's
And scientists generally are prepared for failures.
yeah.
Generally, their mindset
Right.
like this because they always take
Correct.
risk.
And I think it's very important to actually look through those gaps and see uh, whether it is an actual failure or is it something that you can uh, infer from that particular so-called
Yes.
failure. Sir,
Yes.
so I think we have one last question. We will see there are a lot of questions coming. So one question that Vishal has asked is I, I want to be a part of an interplanetary mission on humans, becoming a multiplanetary species. He is aware of astrobiology now, and he's
Mm.
thinking of joining a space agency, but is confused in choosing a better career because he's interested in biology. Okay, can you please guide the student on trying to clarify his confusion?
Okay. Now, astrobiology he can definitely do. He need not sit in a spacecraft and travel because they may select people who can travel in spacecraft using very different criteria like physical fitness and mental fitness, many other parameters. So, if he is interested in astrobiology, there are faculties in Indian Institute of Astrophysics, Bangalore, and TIFR, and many other places in India who actually look at atmospheres of planets outside solar system or within solar system and outside solar system and infer that what kind of species is there, what kind of molecules are they like any signatures of life and many such things. So astrobiology, astrochemistry, astrobiology, they are interlinked. Definitely he can take it up this and there is a lot of scope for it.
Yes, sir. Yeah, definitely. I think Vishal, you can, irrespective of whether you will be a part of an actual space mission or not, definitely you can get into astrobiology as a field and explore that even more. So, we are running out of time. So, a lot of questions coming in, but definitely I think we can have one more such session in the future and
Yes.
take up a lot
Yeah,
more
definitely.
questions. There were a lot of questions. So, before we wrap this up, could you share one favorite space fact? Something that I think all of us should know.
Yeah, no, this black hole is something which is very amazing power. So just give an example that suppose you are doing Diwali crackers. Suppose a cracker is the size of a groundnut, and if you keep that cracker, groundnut size cracker in Kanyakumari and fire it up, the jet will go up to Kashmir.
Oh,
So that much power, that's the power of radio galaxy, the black hole engine in the center.
right.
So that is the kind of power a black hole can have. That is amazing, and it is now with the Event Horizon Telescope, it is actually observationally proved, and even the Nobel Prize also
Right.
is awarded to that kind of
That
work.
is wonderful.
So that is something amazing. Yeah, that's amazing.
It
The
is
power.
astronomy, astrophysics is truly a very, very humbling field. It makes us realize our place in the universe, makes us realize that there is more to our existence than just quarreling among ourselves, trying to fight with each other
Yes,
over very small things that don't even matter in the scale of the universe. So, thank you so much
yes,
for
yes.
being
Thank you.
a guest. In fact, I didn't feel like you were a guest, you are one of our own. So thank you, sir, so much for being here today with us today. Uh, and we are very, very grateful to you. Viewers,
Thank
thank you
you.
all for being a part of this particular session. So, if you haven't done it already, do subscribe to our page, like this video, and make sure you click on the notification bell to get regular updates on such programs that we do every Sunday. Uh, our next Sunday, that is on 8th of November, we have another special guest joining us. We have Dr. Asha Rao. the Associate Dean of RMIT University, Melbourne, all the way from Melbourne, that she is a mathematician. She will be talking about the wonders of mathematical sciences, probably a lot of things that you're not aware of. And all of you should join us, but do make a note that it will not be at 5 p.m. because it is a live show. And since our guest is joining from Melbourne, our next episode, that is on 8th of November, will be at 11 a.m. That is 11 a.m. to 12 p.m. Okay, so 11 a.m. to 12 p.m. Indian time. Uh, Thank you once again to all the viewers for being a part of this journey of success, EduPath. Thank you.